Hi, Algebra 1 students. Today we're going to talk about section 10.5 extension, which is how to graph a quadratic function in vertex form. So we've been practicing graphing our parabolas, and it's a lot of work. So hopefully after this lesson today, you're going to really appreciate what vertex form has to offer. So let's take a look at vertex form. So vertex form is y is equal to a times the quantity x minus h, quantity squared plus k. Okay, so anytime you're in vertex form, you're going to see these parentheses with a quantity inside, and then there's going to be a power of 2 on the outside of those parentheses. So all the different letters in vertex form have a very important meaning in relation to our parabola. So we call it vertex form because the vertex of the parabola is going to be located at the point HK. Okay, so if we can identify the number representing H and the number representing K, we will know where the vertex is without even having to solve. Also, we learned previously that the axis of symmetry always goes through the vertex. So then our axis of symmetry is going to be x is equal to our x value of our vertex, H. Also, when we look at the parabola, the equation of it, we can tell if it's opening up or down by looking at the value of a. So if a is a positive number, if a is greater than 0, that means it's positive, then the parabola is open, it's going to open up. And if the value of a is less than 0, that means if a is a negative number, then the parabola will open down. Okay, so let's take a look at what this looks like on the graph real quick. So you're going to see an equation and it's going to be in vertex form, so you will know where the vertex of your parabola lies. Let's just say it's here in quadrant number 1, okay? And it's going to be the value HK. And then your axis of symmetry is going to go through that vertex. It's going to be a vertical line, and it's going to have the equation x is equal to h. And then you're going to look at the value of a, and if a is positive, you're going to open up around that axis of symmetry. And if the value of a is negative, then you will open down around that axis of symmetry. Okay, so let's look at a few problems here. What we're going to do is we're going to identify the vertex and axis of symmetry for all 4 problems, and then we're going to tell whether the function opens up or down. Okay, so looking at the equation, I'm specifically wanting to look at the value of h and k to determine my vertex. So h is going to be the number 3. Now remember that it's always opposite of what you see. So if it says -3, it's really positive 3 for the value of h. And then 7 is going to be the value of k. Now our axis of symmetry then is going to be going right through that vertex at the x value. So x is equal to our x value of our vertex. And then the value of A is a positive 1. It's a positive 1. We don't see the 1 there because there's no point in writing 1, but it is positive, so we know that the parabola is opening up. Okay, let's try number 2. Let's see here. For our vertex, the value of h, oh, this one says x plus 4. So that means I have to take the opposite of that, minus 4, and then the value of k is 3. So h and k, my vertex is negative 4, 3. My axis of symmetry is going to go through my vertex at the x value. So x is equal to negative 4 is my axis of symmetry. Now this equation is showing that the value of A is negative 1. Since it's negative, our parabola will open down. Let's try number 4. We have a vertex here at, looks like negative 1, negative 8. Okay. Our axis of symmetry then is going to be x is equal to negative 1. That's the x value of the vertex. And our value of A is 2. A is 2. So that's positive. We're going to open up with that parabola. Number 4, our vertex is going to be located at H, which is 5, and K, negative 9. Okay, pay really close attention to those signs. The axis of symmetry is going to go through our vertex, right through the x value, so x is equal to 5. And the value of A on this one is 3. So we're going to open up because that is a positive number. Okay? So what I want you to do is I want you to go ahead and pause the video, and you're going to try problems 5 and 6. You're going to identify the vertex and the axis of symmetry, and then you're going to tell whether the function opens up or down. When you're ready to check your answer, go ahead and resume playing the video, and we'll talk about the answers for problems 5 and 6. Okay, so let's look at the answers here for 5 and 6. Let's see, so when we look at problem 5, we have y equals negative 2 times the quantity of x plus 6 raised to the second power minus 1. So our vertex is going to be at a negative 6 because it's the opposite of what you see in the parentheses, and then negative 1. You always take the same sign for the outside number. The axis of symmetry is going to go through the x value of the vertex, so x equals negative 6. And since A is a negative 2 in this problem, a negative number means we're going to open down. On number 6, we have a vertex of 2, 5. The axis of symmetry is x equals 2. And since A is a positive 4 in this problem, we are going to open up. Okay? All right, so let's look at the rules for graphing in vertex form. So the first thing you want to do is identify and plot the vertex. Okay? Then you're going to draw and label the axis of symmetry. Label it with the equation x equals the h value. Choose 2 values to the right of the vertex, and you're going to use those 2 values to plug them into your equation to find their outputs, in which you're going to plot their outputs. And then you're going to reflect those points over the axis of symmetry, and you're going to have a total of 5 points, and you're going to connect the dots to draw the parabola. So if you haven't copied down the list, I would go ahead and pause the video so you can complete your list, and when you're ready to go and move on, you can resume playing. All right, so let's look at graphing in vertex form. This is exciting. So we want to, step 1, identify the vertex. So our vertex is going to be located at, positive 3, 2. Okay? And our first step was to identify that vertex and then plot that vertex. So let's get that on our graph here. All right, so 3, 2 is where my vertex is. Okay, I'm going to label that because I really like to do a good job labeling everything just so I know exactly what's going on here. All right, so our axis of symmetry is the next thing we're going to do. Now our axis of symmetry is going to be a vertical line that goes right through the vertex at its x value. So x equals 3. So we're going to plot that vertical line and we're going to label it. So there is our axis of symmetry and we're going to label it x is equal to 3. Okay? Now the third step is going to be to take 2 points on the right of our vertex. Okay, so our x value at our vertex is 3. I'm going to make a table here, and I want to choose 2 points to the right of that value 3. So how about 4 and 5? Okay, now I'm going to take those values and I'm going to plug them into my equation, and I'm going to find their outputs. So let's start with 4. We're going to plug 4 in here. 4 take away 3, quantity squared plus 2. So 4 take away 3 is 1. So 1 squared plus 2 is going to give us 3 as our output. And then plugging in 5, 5 minus 3, quantity squared plus 2. So 5 take away 3 is going to be 2 squared. So 2 squared is 2 times 2, which is 4, plus another 2, which is 6. Okay, so we plug our numbers in, we've found their outputs, and now we're going to plot these 2 points. So we have the point 4, 3, and we have the point 5, 6. Now my next step is to reflect these points over my axis of symmetry. So I'm going to bring them across and line them up here. And now I have a total of 5 points. Okay, so now I can connect those points. And remember, parabolas are like a U shape. They're not a V shape. So you want to make your dots look like they're kind of curving and making that U shape. Okay, let's try another one here. We're going to do the equation y is equal to negative times the quantity x plus 4 squared plus 5. Okay, so our vertex is going to be located at the point negative 4, positive 5. Okay, now the axis of symmetry on this problem is going to be the equation x is equal to negative 4 because it goes through the x value of your vertex. And the value of a, in this case, is a negative 1 because I see a negative outside of the parentheses. So since that value of a is negative, we're going to be opening down with our parabola. Okay, so let's get what we know plotted on our graph, and then we're going to choose some points. Now let's think about this. Where is the point negative 4, 2? Let's see, I would have to start at my origin. I would go to the left and then up, the left 4 and up 5. So that puts me in quadrant 2. So when I'm drawing my graph, if I know I'm opening down and I'm supposed to be in quadrant 2, then instead of drawing the entire x and y axis, I'm just going to be kind of focused in on quadrant 2. Okay? Okay, so let's see, we got our vertex here at negative 4, 5. Negative 4, 5 is our vertex. And then we have our axis of symmetry, which is going to be x is equal to negative 4, goes through the vertex and then through the x-axis at negative 4. And I'm going to label that x equals negative 4. Okay, I'm going to also label my vertex. My vertex is negative 4, 5. Okay? Now our next step is to choose 2 points on the left side, or excuse me, the right side of our vertex. Choose 2 x values, and we're going to use those to make a table here. Okay, so if my x value of my vertex is negative 4, then let's choose like negative 3 and negative 2. Those are 2 numbers to the right of my vertex. I'm going to plug them into my equation. I'm going to be really careful with my math. So negative 3 plus 4, quantity squared plus 5. Okay? On the inside of the parentheses, negative 3 plus 4 is a positive 1. So I have a negative and then a positive 1 squared plus 5. Positive 1 squared is positive 1. And then we have to multiply by a negative 1. So we get a positive 4 out. Negative 1 plus 5 is a positive 4. Okay? Let's try plugging in negative 2 this time. Okay, so let's see. Negative 2 plus 4, quantity squared plus 5. On the inside of my parentheses, I'm going to have a negative 2 plus 4 is a positive 2 squared. I have a negative sign outside. So positive 2 squared is going to be 4. So negative 4 plus 5 makes a positive 1. Okay? So let's see here. Let's get these points plotted up here. We have a negative 3, 4, and then a negative 2, positive 1. And I'm going to reflect these points over my axis of symmetry, keeping them nice and aligned, and then drawing my parabola, connecting the dots to draw my parabola. Okay? All right, let's try another one. This time we have the equation 3 times the quantity of x minus 2, quantity squared here. Now, I don't see a k value for my vertex. What would my value of k be? Yes, I know what you're thinking. It would be 0, because it'd be the same thing as plus 0 there. Okay? So our vertex is going to be at 2, 0. Now our axis of symmetry is going to go through that vertex at our x value. So it's going to be located at x equals 2. Okay? And then let's see, are we going to open up or are we going to open down? Well, for this one, a is positive 3, so we are going to be opening up. So let's get this plotted. Now, where is our vertex? Let's see, to plot my vertex, I would start at the origin, I would go right 2 units, and then I wouldn't go up or down at all. So I'm going to be right on the positive x-axis in between quadrant 1 and quadrant 4. So when I draw my graph here, let's see, I want to kind of focus in on that portion. So more on quadrant 1 here, because we know we're going to be opening up. Okay, so let's see, our vertex 2, 0, there's my vertex. My axis of symmetry is going to go right through that vertex. And we're going to label that axis of symmetry x equals 2. We're going to label our vertex as well, 2, 0. Okay? Now we want to choose 2 points to the right of our vertex. So how about 3 and 4? Those points sound good. So let's see here. I'm going to plug 3 into my equation here to find the output. So that's going to give me 3 times 3 minus 2 squared. And 3 minus 2 is 1. So that gives us 3 times 1 squared. And 1 squared is 1. So that's 3 times 1. So that gives us an output of 3. Now, when I plug 4 in, I'm going to have 3 times 4 minus 2, quantity squared, and 4 minus 2 is 2, so 3 times 2 squared. 2 squared is 4, so that gives us 3 times 4, which is 12. So that's our output. Okay, so we're going to plot these points, 3, 3, and 4, 12. So 3, 3, and 4, 12. Now, my next job is to reflect these points over our axis of symmetry. Okay, so reflecting them over, keeping them nice in a line there, and then we draw our parabola. Okay, now this parabola is very skinny because our value of A is 3, so we're stretching it. We're stretching it way up the y-axis there. All right, so what you're going to do is you're going to practice and show me that you understand how to graph in Vertex form. So what I want you to do is I want you to pause the video and you're going to graph problems 4 and 5. You're going to label the vertex and the axis of symmetry. When you're ready to check your answer, go ahead and hit play on the video, resume playing, and we'll talk about the answer. Okay, so let's look at the answer for problem 4. We have a vertex at -2, -3. We can see that from the vertex form for our quadratic. The value of A is +1, so we know we're going to open up, and our axis of symmetry is -2. So I plotted my vertex at -2, -3. I drew my axis of symmetry, and I chose 2 points to the right of my vertex. So I chose -1 and 0. I plugged those in to the function to get their outputs. And then I plotted those outputs. And then what I did after that is I reflected those points over my axis of symmetry and then drew the parabola. For number 5, we have a vertex located at 1, 6, and we have an axis of symmetry then at x equals 1. Because the value of A is -2, that means our parabola will be opening down. So plot your vertex, draw your axis of symmetry, and the next thing is to make a table choosing 2 points to the right of your vertex. So I chose the points 2 and 3 because my vertex started at the x value of 1. I plugged those in, I got their outputs, which is 4 and -2. I plotted those 2 points, I reflected them across the axis of symmetry, and then we drew the graph. Okay? I hope you are going to appreciate graphing in vertex form. I sure like it. It's one of my favorite forms. It basically cuts down on a lot of the solving and extra work we have to do to graph a parabola. So I hope you enjoyed the video and have a lovely day. Thanks for watching.